Welcome to Math 1151 Final Exam Review Problems. Well, firstly, we look at the problem about the position and velocity functions. So here we're given the acceleration function ax equal to negative 2x, the initial velocity v0 equal to 10, and the initial position s0 equal to 40, and we want to find the position function and the velocity function. Because the position function is based on the velocity function, so it will be better for us to find the velocity function first and then find the position function. Okay, so by the formula, we know that the velocity function vt is equal to v0, that is the initial velocity, plus the integral of 0 to t of ax dx. Okay, and here the ax is the acceleration function. And then we're going to plug in the numbers, because v0 from the problem, we know that v0 is equal to 10. The initial velocity is equal to 10, plus the integral of 0 to t of ax, and here ax equal to negative 2x of dx. And if we use the fundamental theorem of calculus, we know that this is equal to negative x squared with the bound of t and 0. And then if we plug in t and 0 into the function negative x squared, we will have 10 plus negative t squared minus negative 0, and we have 10 minus t squared, and this is the velocity function. And then based on this, we're going to find the position function. Remember, the position function is given by st equal to s0, that is the initial position, plus the integral of 0 to t of the velocity function vx dx. Okay, so here we have s0, that is the initial position, is equal to 40, plus the integral from 0 to t of the velocity function, that is we've already found in the first part, that is 10 minus x squared of dx. We can just, because t here is just a dummy variable, we can just replace x by t. Okay, then we're going to evaluate this part of the integral. We have 40 plus the antiderivative of 10 minus x squared is 10x minus 1/3 of x cubed, and the limits are t and 0. And here we are applying the fundamental theorem of calculus. And then if we do the calculation, we have 40 plus 10t minus 1/3 times t cubed, and this is our final result for the position function. Alright, this is the first part. Now we look at a somewhat complicated case, and here we have the acceleration function ax is equal to 2x over x squared plus 1 squared. Okay, so we are going to firstly find the velocity function, that is vt equal to v0, that is the initial velocity, plus the integral from 0 to t of the acceleration function ax dx. And if we plug in the numbers, we know that the initial velocity is equal to 0, that is the first part is equal to 0, so we only have the integral part, that is from integral from 0 to t of 2t over x squared plus 1 squared dx. Okay, and now we're going to integrate this part, and actually we can do a change of variable, and we're going to let u to be x squared plus 1, and then du is equal to 2x dx. Okay, we differentiate the left hand side with respect to u, and then we differentiate the right hand side with respect to x, and we will have du equal to 2x times dx. And then we're going to solve for the x, and this is equal to du over 2x. Alright, this is the setting for changed variable. But if we change the variable, we will have to also change the integral limit. So for the lower limit, the previous limit is 0, that is x equal to 0. We're going to plug 0 into this function. We have u0 equal to 1. So the new integral lower bound is equal to 1. And plug the upper bound into u function, we have ut equal to t squared plus 1. So the new upper bound of the integral is equal to t squared plus 1. And now we plug all the pieces into our integral. We will have the lower bound becomes 1, the upper bound becomes t squared plus 1, and then we keep 2x. You will see why we do that, over x squared plus 1 squared. Now it is equal to u squared. And then we're going to replace dx by, and look at this part of the result, dx equal to du over 2x. And now you can see we can cancel the 2x on the numerator and in the denominator. And now we actually have the integral from 1 to t squared plus 1 of du over u squared. And of course you know that the antiderivative of 1 over u squared is equal to negative 1 over u. And remember our integral limits are t squared plus 1 and 1 respectively. And then plug in by using the fundamental theorem of calculus, we will have negative 1 over t squared plus 1 and then minus negative 1. So it is equal to 1 minus 1 over t squared plus 1. Okay, this will be the result for the velocity function. And next, we're going to find the position function, that is st equal to s0 plus the integral from 0 to t of the velocity function vx dx. So if we look at the problem, we see that the initial position s0 is equal to 0. So the first quantity is equal to 0, so we only have the integral. That is 0 to t of 1 minus 1 over x squared plus 1 dx. Okay? Because again, t is just a dummy variable, we can replace t by x. And then, by linearity of the integral, we can rewrite this as the integral from 0 to t of 1 dx minus 0 to t of 1 over x squared plus 1 dx. For the first part, it is x with a limit of t and 0. And for the second part, the antiderivative of 1 over x squared plus 1 is just arctangent of x. And our integral limits are t and 0. If we calculate this out, it is equal to t minus the arctangent of t. Okay? This is the final result for the position function.